Atop the massive 730,000-pound, 19-story high Atlas V sits the InSight lander. Nearly 800 pounds of state-of-the-art science. Destination, Mars.
7, 6, 5, 4, 3, 2, 0. Liftoff of the Atlas V, launching the first interplanetary mission on the West Coast.
Once again, Mars is calling. For over 50 years, we've visited Mars. And a new mission is on its way to the underground world of the Red Planet. For the first time ever. Over 6 months after liftoff, InSight will arrive at Mars at a speed of 13,200 miles per hour. And 80 miles above ground, 3.5 minutes later, it'll still be roaring along at over 900 miles per hour when the parachute deploys. A half mile from the surface, it's at a snail-like 136 miles per hour. As onboard thrusters are guiding the spacecraft. In about 40 seconds, it's touchdown, if all goes well. For the InSight team, 6 terrifying minutes await. And then it's back to the business of exploring Mars.
The basic idea of InSight is to map out the deep structure of Mars for the very first time. We're going to map out the thickness of the crust, the size of the core, sort of get the first map of the inside of Mars.
Past missions have only scratched the surface when it comes to our knowledge about Mars. However, InSight will soon look deep into the planet to uncover tectonic activity and learn how this rocky planet was formed.
We don't know very much about what goes on 2,000 miles below the surface. And this will be the first mission to investigate the huge extent of Mars below the surface.
InSight takes a look at the heart of Mars and conducts the planet's first checkup since its birth, 4.5 billion years ago. The lander's tools will help uncover tectonic activity and the process that shaped the rocky planets of our solar system. Of the primary tools, the first science instrument to be deployed will be SEIS, a seismometer to measure the vibrations caused by internal activity.
It gives them an idea of what the size of the crust, the mantle, and the core are, as well as the properties of each of those.
JPL built an almost identical replica of the lander and created a test bed of its landing site from satellite photos of Mars. Today, the engineers attempt to attach the wind and thermal shield to the seismometer.
Wind and thermal shield consists of this dome right here, this part, as well as a skirt that is made of mylar. That's this gold accordion part, as well as chainmail. So this falls down and accounts for any unevenness in terrain and still falls nicely over those features.
Without the shield, the vibrations from even a butterfly would cause problems. The seismometer senses Mars quakes.
We'll be able to use the signals they produce that travel throughout the entire body of the planet to probe the interior of Mars, to look at the size of the core, to understand that molten versus solid structure.
Mars is a record of an earlier geological era.
Mars cooled faster so that it never had plate tectonics, as far as we can see, and it no longer has a magnetic field. It preserved what it looked like early on when it formed, and therefore have a record of what the solar system and the rocky bodies might have looked like about 4 billion years ago when they actually were created.
InSight took nearly 10 years of worldwide research and development, much of it in Pasadena, California, at the Jet Propulsion Laboratory. Here, the InSight team tested the HP-3 heat probe, a vital tool to measure the heat levels inside Mars. The heat probe tells us about the amount of heat energy available today to drive geologic activity. The probe takes Mars's temperature, and when it reaches full depth, HP-3 will be completely isolated from the surface, sensitive only to the slow trickle of Mars's primordial heat.
We're basically going to play the claw game on Mars. We've got a few instruments here. We've got the heat flow probe right there. So inside this part of HP is a mole. It's like a self-hammering nail. So it'll hammer down into the surface of Mars to a depth of 5 meters.
It periodically measures the properties of the soil as it burrows into the planet. Embedded on the trailing tether are 14 temperature sensors at varying intervals. They'll monitor temperature levels beneath the surface. Depending on distance covered and ground characteristics, scientists estimate that between 5,000 and 20,000 strokes will be needed to complete the probe's work.
Today we do not have the solar arrays installed on the lander in the test bed. So the solar arrays are deployed after landing within about 10 minutes, and they provide energy to charge the batteries on InSight and then power all the components on the spacecraft.
In the weeks before the May 5th launch bound for Mars, a team checked out the solar arrays before packing up. Destination, Vandenberg Air Force Base, the launch site for the InSight lander mission. After delivery to the Air Force Base clean room, InSight got a final checkup before the May launch.
It's amazing. We're going to be the first mission to actually look at the inside of Mars and probe the unseen interior, which we can not only apply to Earth, but also formation of rocky planets across this solar system. And so this may teach us about rocky planet formation across the universe.
It's going to Mars to do the science, to make the measurements that scientifically and personally I've been waiting over 30 years for.
But on November 28th, 2018, we will see Mars in a new light as InSight probes the depths of the red planet for the first time.